Ever wondered who was behind the famous Fermat's last theorem? The man of the hour, Pierre de Fermat, was a beacon of mathematical brilliance in the 17th century, a time when the subject was blossoming into the intricate field we know today. Born in the year 1601 in Beaumont-de-Lomagne, France, Fermat's life was anything but ordinary. While his day job saw him don the robes of a jurist, treading the corridors of law, his true passion lay hidden in the intricate world of numbers. Fermat's fascination with mathematics was not just a hobby, but a fervent pursuit that would lead him to etch his name in the annals of mathematical history. But what drew Fermat to the world of mathematics? It was his insatiable curiosity and love for a good challenge that propelled him into the depths of number theory, a field that was largely unexplored at the time. This passion, combined with his innate talent, led him to become a trailblazer in the development of differential and integral calculus, even preempting the discoveries of other notable mathematicians of his era. However, the jewel in Fermat's mathematical crown is undoubtedly his last theorem. This theorem, scribbled in the margins of Diophantus's Arithmetica, became one of the greatest mathematical enigmas of all time, enticing and confounding mathematicians for centuries. Fermat claimed to have a proof, elegant in its simplicity, but this proof remained a mystery, lost in the margins of history. Fermat's life and work were shrouded in a certain level of mystery, a trait that has only added to his allure in the mathematical world. Despite his prominence in the field, much of his work was only known through his letters and notes, often written in the margins of his books. His enigmatic nature is best reflected in his marginal notes in his copies of classical works. These notes, often cryptic and always intriguing, offer a glimpse into the mind of one of the greatest mathematicians of the 17th century. A man who, driven by curiosity and challenge, left an indelible mark on the world of mathematics. Fermat was a pioneer in many areas of mathematics. Notably, he was instrumental in developing the foundations of differential and integral calculus, fields that are considered cornerstones of modern mathematics. Fermat's work in these areas was truly ahead of his time, as he anticipated discoveries that would later be made by other notable mathematicians. His approach to calculus was based on his profound understanding of algebra and geometry, which allowed him to conceptualize and solve complex mathematical problems in innovative ways. One of his significant contributions to calculus was his method for finding the tangent to a curve, a fundamental concept in differential calculus. Fermat's approach was unique and ingenious. He introduced the idea of adequality, a precursor to the concept of limits, to compare infinitesimal differences and calculate the slope of the tangent line to a curve at a particular point. Fermat's work in integral calculus was equally groundbreaking. His method of finding areas under curves laid the groundwork for the fundamental theorem of calculus, which demonstrates the deep connection between differentiation and integration. This theorem, though not formally stated by Fermat, clearly bears his intellectual imprint. Fermat's contributions, however, extended beyond the realm of calculus. He was also an early pioneer in the field of probability, providing solutions to problems of chance that would later form the basis of statistical analysis. Yet, it was in number theory that Fermat truly left his mark. He made numerous contributions to this field, including the introduction of Fermat numbers and his work on the properties of prime numbers. These contributions were instrumental in advancing our understanding of these fundamental mathematical concepts. But his most famous work lies in the realm of number theory, particularly Fermat's last theorem. This theorem, which puzzled mathematicians for centuries, is a testament to Fermat's innovative thinking and his ability to challenge conventional mathematical wisdom. It underscores his legacy as a pioneer in mathematics, whose work continues to inspire and influence the field to this day. Fermat's last theorem, a note in the margin of Diophantus's Arithmetica, became one of the greatest mathematical mysteries. Imagine a seemingly simple equation. Three positive integers, a, b, and c, are in a relationship where a circumflex n plus b circumflex n equals c circumflex n. But there's a catch. The n in this equation is an integer greater than 2. This is the crux of Fermat's last theorem. It might sound straightforward, but this theorem has been a conundrum that puzzled mathematicians for centuries. In a margin of his copy of Diophantus's Arithmetica, Fermat wrote this theorem, adding with a certain flair that he had a truly marvelous proof for it. But alas, this proof was too large to fit in that margin. And just like that, the chase was on. The hunt for this elusive proof became a beacon for mathematicians worldwide. Fermat's last theorem was like a siren call to mathematicians. It was a simple equation that seemed like it should be solvable. but no one could find a proof. The theorem was tantalizingly straightforward, yet devilishly complex. It was a paradox, a riddle wrapped in an enigma, and it was this tantalizing mystery that drew mathematicians to it like moths to a flame. Fermat himself was quite the enigma. A lawyer by trade, he was a self-taught mathematician who made significant contributions to a variety of mathematical fields. But it was this theorem, this simple notation in a margin, that became his most famous legacy. In his notes, Fermat claimed to have an elegant proof for this proposition. However, he never shared this proof. And so, the theorem remained unproven for over 300 years. It was a challenge that called out to mathematicians, a puzzle waiting to be solved. The beauty of Fermat's last theorem lies not only in its simplicity, but also in its mystery. It's a testament to the allure of the unknown, to the irresistible draw of a challenge. This theorem remained elusive for centuries, sparking curiosity and challenge among mathematicians worldwide. The proof of Fermat's last theorem only emerged in the late 20th century. This was centuries after Fermat's original conjecture, and it came through the determined efforts of two mathematicians, Andrew Wiles and Richard Taylor. Wiles, a British mathematician, had been fascinated with Fermat's last theorem since he was a child. Intrigued by the mystery and the challenge it presented, he dedicated a significant portion of his career to cracking this centuries-old mathematical enigma. He wasn't alone in his pursuit. Wiles collaborated with Richard Taylor, an American mathematician, and their combined efforts led to a breakthrough. But this was no overnight success story. Years of hard work, countless trials, and numerous setbacks marked their journey towards the proof. They employed a technique called the Taniyama-Shimura-Weyl conjecture, which links elliptic curves to modular forms. Wiles and Taylor's proof was a testament not just to their individual brilliance, but also to the power of collaboration in mathematical research. Their proof, presented in the 1990s, was a monumental achievement. It not only solved Fermat's last theorem, but it also opened up new avenues of research in the world of number theory and mathematics as a whole. Wiles and Taylor's success highlighted the depth of Fermat's conjecture. It showed that even a simple equation, jotted down in the margin of a book, could hold profound mathematical truths waiting to be discovered. Their work also underscored the importance of persistence in mathematical research. Fermat's last theorem had remained an unsolved mystery for over 3 centuries. It had challenged some of the greatest minds in the history of mathematics, yet it was the relentless determination of Wiles and Taylor that finally cracked it. Their journey to find the proof of Fermat's last theorem is a testament to the enduring power of curiosity and the thrill of the challenge that drives the world of mathematics. This monumental achievement underscored the significance of Fermat's contributions to mathematics. Fermat's conjecture, once an enigma, had finally been proven, and the proof was worth the wait. Fermat's legacy extends beyond number theory. Indeed, his influence also radiates into the field of geometric optics. He developed what we now know as the principle of least time, a fundamental concept in optics. This principle states that light always travels along the path that takes the least time, giving us insight into how we see the world around us. Imagine you're a lifeguard at a beach and you spot a swimmer in trouble. You want to get to them as quickly as possible. You could run straight into the water, but running is slower than swimming. Or you could run along the beach to a point directly opposite the swimmer before swimming straight towards them. But that's not the fastest route either. The quickest path, as Fermat figured out, is a compromise. You run a bit, then you swim a bit, taking the path that gets you to the swimmer in the least amount of time. That's the principle of least time in action. But Fermat's legacy isn't just limited to his mathematical discoveries. His enigmatic nature, his habit of jotting down theorems without proof, his penchant for puzzle solving, these all continue to inspire generations of mathematicians. His work embodies the spirit of mathematical exploration, a mix of curiosity, creativity, and the thrill of solving a challenging problem. In many ways, Fermat's approach to mathematics reflects the essence of scientific discovery itself. It's about asking questions, pushing boundaries, and not being afraid to venture into uncharted territory. It's about the joy of the journey as much as the satisfaction of reaching the destination. So, as we delve into the intricacies of number theory, or marvel at the beauty of geometric optics, let's remember the man who made significant contributions to these fields. A jurist by profession, a mathematician by passion, who saw the world through the lens of numbers and equations. Pierre de Fermat, who passed away in 1665, left a lasting legacy in the history of mathematics, reminding us that curiosity and challenge can lead to significant discoveries.